Hello class, for this video, we will be solving singly reinforced beam. So we will start with this problem. In accordance with this provision of the 2010 and also 2015 NSCP, the required strength U shall be at least equal to the effects of the factored loads below, where the effects of one or more loads not acting simultaneously shall be investigated. So here we have U natin is 1.4 dead load, 1.2 dead load plus 1.6 live load, 1.2 dead load plus 1.6 live load plus 0.8 na wind load. Meron din tayong 1.2 dead load plus 1 earthquake load and 1 live load. And lastly, yung 0.9 dead load plus 1.6 wind load. Okay? So results from elastic analysis of a concrete beam yields the following values of the unfactored or shall we say service moment. So dead load moment natin is 50 kilonewton meter. We have live load moment 80 kilonewton meter. Wind load moment natin is 60 kilonewton meter. Sorry. And earthquake moment natin is 100 kilonewton meter. So steel proof protective covering is 75 millimeters to the centroid of the steel group. So FC prime natin, yung strength of our concrete is 28 megapascal. And F1 natin is 415 megapascal. Assume bars to be placed in one layer only. So first thing that we need to determine is the value of the factored moment that will be used in designing this member. So we will be solving or we will be substituting these values to these 5 formulas and hahanapin natin saan yung pinakamalaki. Kasi yan yung gagamitin natin na factored moment for this problem. Okay? So, but for that, no, but matagal tayong matapos, di ba? So, we will just be solving this one and this one because I am confident that nandito lang silang dalawa yung ating malaki na value. Okay? So, for this one, number 1 natin, we will be first using this equation. So, U natin, ang ultimate load or ultimate factored load is 1.2 dead load plus 1.6 live load plus 0.8 of our wind load. So, substitute lang po natin plus 1.2 dead load natin would be 50 kilonewton meter plus 1.6. Then live load natin would be 80 kilonewton meter. And then lagyan natin ng wind load which is equivalent to 0.8. 60. Okay? So by using the calculator, ang kalabasan po nito is 236 kilonewton meter in a moment. So how about this one? We will be using that one and check natin kung saan yung mas malaki sa kanilang dalawa. So U natin is equivalent to 1.2 dead load plus 1 yan, earthquake load plus another 1 live load. Ayan po. So, same pa rin kanina, substitute natin yung values. 50. Dito is 80. Sorry. Not 80. Earthquake natin is 100. Yan po. And then last is yung ating live load, which is 1.6. Same pa din, by using our calculator, the result is equivalent to 240 kilonewton meter. So therefore, if you will compare the two, ang summation nila, mas malaki yung 240, so we will be using 240 kilonewton meter. And that is the answer for our number 1. Ayan, so continue tayo. So for number 2, ang hinahanap natin is the required dimension using the maximum allowable reinforcement ratio for the tension control. So binigyan tayo ng 4 choices, 30 or 300 multiplied by 450, 275 by 475, 200 by 500, 250 by 400. So, therefore, i-check natin kung saan sa apat yung dapat natin gamitin. Diba? Okay, so sulat na natin kanina, na-solve natin that we will be using our ultimate factor load, which is 240 kilonewton meter. Yan. Okay, so take note dito yung sabi niya is using the maximum allowable reinforcement ratio for tension control. So, yung topic natin ng first video, yung sa derivation of formulas, ito po yung formulas natin for tension control. So, sabi doon, maximum daw na rho if we are in our tension control. So, therefore, this is our rho maximum. So, sabi ko doon na video na i-equal natin sa formula na to if we are talking about maximum tension control. Diba? So, therefore, we will be using this formula. Okay? So, sulat lang natin rho maximum for tension control. Yan. Is equivalent to 0.85. Sorry. Yan. FC prime divided by Fy natin multiplied by beta and multiplied by 3 over 8 kasi tension controlled tayo. Okay? So therefore, substitute na natin yung kanyang mga values, 0.85. Binigyan tayo ng Fc prime which is equivalent to 28 megapascal. Yan. Divide natin ng ating Fy or strength ng ating reinforcing steel. Multiplied by our beta. So as you can see here, yung ating beta is, or shall I say, yung ating Fc prime is 28 megapascal. Diba? So equivalent siya. So therefore, the value of our beta is 0.85. Diba? So review natin yan na andoon sa itaas. If our beta Fc prime is equivalent to or less than 28 megapascal, we will be using beta which is 0.85. Yan. So therefore, if mas malaki siya, ito na yung gagamitin natin ng formula in determining our beta. Okay? So tayo, 0.85 multiplied by 3 over 8. Therefore, that is our tension. Okay, so by using our calculators, check na lang din para ma-practice din kayo how to calculate this one. Diba? So, by using our calculator, the answer is equivalent to 0.01828. Again, paki-check if tama ba siya. Pagkatapos, natin kunin yung rho maximum natin. So, gagamitin natin yung ating general formula in our rho. Sulat natin yung formula. Rho is equivalent to 0.85 Fc prime divided by Fy. Ayan. Then, multiply natin, open parenthesis, 1. Then, the square root of 1 minus 2Rn divided by 0.85 Fc prime. Ayan. Okay? So therefore, by using this one, substitute natin kasi rho maximum in tension control yung gagamitin natin. So substitute natin 0.01828. Equivalent to 0.85. Fc prime natin is 28 divided by Fy, which is equivalent to 415, open parenthesis, 1 minus square root of 2 multiplied by Rn. So therefore, Rn yung makukuha natin dito by using the function of our calculator, which is yung shift solve. Diba? So if hindi na siya available or hindi na yun pwede sa board exam na calculator, so ano-mano lang, nailipat mo lang lahat hanggang Rn na lang yung remaining. Okay? So multiplied by 28. So therefore, by using our calculator, makukuha natin si Rn, which is equivalent to 6.38. Ayan. Okay, so pag nakuha na natin si Rn, pwede natin makuha yung ating required na BD squared, no? Or ang ating base tsaka depth, which is i-compare natin sa kanilang apat, kanino o saan tayo o ano yung pipiliin natin sa apat na to. Okay? So, take note that we have a formula sa ating resisting moment or Rn, which is equivalent to mu over C BD squared. No? So, gagamitin natin yan, Rn, that is mu, nakalimutan ko na kaagad, no? Mu, sorry, Rn mu BD squared. So, lagay natin dito, Rn is equivalent to P mu, then divided by BD squared. So, therefore, lagyan natin ganyan, 6.38 yung ating Rn. Phi natin is equivalent to 0.9, di ba? If we are dealing with 2000 and slash 2015 na NSCP. And then, mu natin yung kanina, di ba? Ito, nasa itaas. This is our mu, which is 240. So, kilonewton meter yan, so we need to convert that into Newton millimeter, di ba? Para ma-cancel out na sa baba, which is millimeter squared. So therefore, multiply natin 240, multiply natin siya ng 10 to the power of 6. Ayan. Kasi yung kilonewton, gagawin natin Newton, and meter natin, gagawin natin millimeter. Okay? So divided by, ayan, BD squared. Ayan. Yan yung hinahanap natin, yung combination ng BD squared. So therefore, 6.38 is equivalent to 0.9 multiplied by 240 times 10 to the power of 6. So, lagyan na natin ito sa kabila. BD squared natin is equivalent to 41, no, by using your calculator, 0.8 times 10 to the power of 6. Ayan siya. So, hindi pa yan yung final answer yet. That is just a combination na gagawin natin sa kanilang apat. Then, para malaman natin kung saan sa apat yung gagamitin natin. Okay? So, copy natin yan. So, copy lang natin, class. BD squared natin is 41.8. So, BD squared natin is 41.8 times 10 to the power of 6. So, i-try natin to lahat, itong apat, then tingnan natin kung sino yung pasok sa BD squared natin. Okay? So, first one is our section. Ayan. Then, yung ating B or depth in millimeters. Then, yung BD squared natin in millimeters times 10 to the power of 6 times 10 to the power of 6 millimeters cubed. Tapos, yung ating remark, if fail ba siya or safe ba siyang gamitin. And then, yung area natin. Okay? So, section natin na unang gagamitin is yung 300, yung letter A, by 450. Therefore, sabi kanina, yung ating steel protective covering is 75. So, therefore, 450 minus 75. Ang depth natin or effective depth would be 375. BD squared natin. So, therefore, B natin is 300. Then, square mo si 450. Clear ba? 300 times 450 times 450. So, therefore, that is 42. 0.18 times 6 times 10 to the power of 6, diba? Okay, so remark, pag-compare natin BD squared natin na pinakamaliit na pwede sa ating loads is 41.8. So pasok siya Kasi 42.18. Center lang natin siya. 42.18. So, compare natin, mas malaki siya. So, therefore, safe siya. Okay. So, next thing is yung area. Para compare natin mamaya, di ba, kung sino yung mas economical. Sabi dito, no? Baka dalawa yung pasok, so therefore maglalaban na lang sila kung sino yung mas maliit yung area. So yung pipili natin yung mas maliit na area para mas economical. Okay? So therefore, multiply na natin 300 multiplied by 450. That is area natin in millimeter square. So lagyan na natin na area millimeter square. Yan. Okay, dito natin. Area. Hindi siya nagkasya. Remark. Area. Millimeter. Yan. Okay? So, area niya is just 300 multiplied by 450. And that is equivalent to 135,000. Ayan. So, how about this one? Try natin si 275 by 450. So, depth niya, 450 minus 75. Sorry. So, 475. So, 475 minus 75, that is clearly 400. Yung ating BD squared, so 275 multiplied by 475 multiplied by 475, that is sakto 44.00. So therefore, mas malaki siya sa BD squared natin na na-solve. So therefore, this is A. Diba? So multiply natin yung kanyang area. 275 multiplied by 475. That is equivalent to 130.625. Ayan. So how about this one? 200, no? Palitan pa natin. Then, palakihan natin yung kanyang depth, 500. So therefore, yung depth natin, 500, effective depth natin is 425. BD squared natin, 200, 500, 500. So therefore, that is 36.12. Diba? So therefore, as you can see, mas maliit na siya sa ating BD squared na nakuha. So therefore, this is unsafe or failure. Fail. Again natin. So therefore, we don't need to solve this area. And then, lastly is 250 by 400. So therefore, yung depth natin is 325. Yung ating BD squared is 26.40. So clearly, mas maliit siya sa BD squared. So this is marked as failed. No? So we don't need to solve for this area. So therefore, tingnan natin yung realization. Pwede natin gamitin yung 300 by 450. Pwede din si 275 by 475. So therefore, ano yung pipiliin natin? So, next thing that we need to check is the area. Diba? 135,000 millimeters square. Ang isa is 130,625. So, clearly, mas maliit yung area ng ating letter B, which is economical. Diba? So, mas maliit na cement na lang yung gagamitin natin. So, therefore, clearly, na ang gagamitin natin is yung letter B. Use 275 by 475 millimeter na section. So, lagyan natin ng remark safe and most economical. Yeah. Okay? So, therefore, lagyan natin ng circle. And circle natin yung answer, which is letter B. Okay ba? So, I think we can proceed to our third na situation. Ayan, so continue tayo. We have here We need to solve or determine the number of pieces na 28 millimeter na diameter tension bars for the above condition. So, yung na-solve natin kanina, yan yung gagamitin natin. So, firstly, yung ating MU, which is yung U natin, di ba, is 240 kilonewton meter. Then, kanina, yung RN natin, that is 6 point, I think that is 6.38. Yan, 6.38. Diba? Kasi we will be using that one. Yung ating section. Section na gagamitin natin is 275 by 475 na total depth. Yan. And then, ano pa? Yung pwede. Yung ating raw. Diba? Kanina. Na-solve natin na raw na ating gagamitin is yung raw maximum. Diba? 0.01828. 0.018. Okay? So, I think that's it. Let us continue with this one. So, kanina, yung ating na-solve na section is 275 by 475. So, therefore, clearly, ilagay natin yung ating mga formulas na gagamitin. Yung isang formula na gagamitin natin is yung moment equivalent to P times Rn dt squared. So, saan yan galing na formula? Dito lang po yan galing. Dito. Nilipat lang po sa kabila. Then, yung mu yung nag-stay sa other side. Ayan siya. MURN dt squared. So, clearly, meron na tayo dito lahat. Ang kulang lang natin is yung D. Yung depth natin. Diba? So, yung D natin, diba, we need to solve that one using our other formula, which is yung ating rho. Diba? Ganito na lang dito. Rho is equivalent to AS over BD. Okay? So, we will be using this one, or we will be substituting the value of D coming from here para yung ating makukuha is yung area ng C na lang. Okay? So, therefore, lagyan natin to, shift natin yung D sa kabila. D is equivalent to AS divided by rho times our D. So, substitute natin dito sa ating D. Okay? So, I think, kompleto na tayo. So, lagay natin dito 240 multiplied by 10 to the power of 6 kasi kilonewton meter. We need a Newton millimeter na result. Then, yung ating C, which is 0.9. Rn natin is 6.38. Diba? Sorry. Ayan, 6.38. Then, B natin, which is 275. Then, yung ating depth, which is AS over rho B. Diba? Talagay natin dito, area ng steel. Hindi pa natin alam, yun yung hinahanap natin. Divided by our rho, which is 0.01828 multiplied by our base, which is 275 by 475, diba? So, ang base natin is 270. Ayan. So, erase lang natin. Okay? So, by using our calculator, shift solve lang natin yun na function. Yung ating area ng steel is equivalent to 1959.8 millimeters. Ayan. That is our final answer. Diba? Pero hindi pa yan ang final answer. Kasi yung nahanap natin is number of steel. So, therefore, we will be using our last na formula for this one. Number of steel natin is equivalent to area ng steel divided by ng area ng isang bar na gagamitin mo. So, therefore, that is 1959.8 millimeters. Ayan, divided by the area of the bar. The area of the bar, that is pi d squared over 4. So, pi natin, diameter is 28 square over Therefore, using our calculator, the exact answer is 3.18, no, pieces. Okay? So, yan yung number of pieces, di ba? Pero wala naman din sigurong bakal na 0.18. And take note, class, ang ginamit natin na raw, di ba, is tension control na maximum. So therefore, this is an exemption, ha? Palagi tayo nag-round up, pero for this one, kasi maximum na yung ginamit natin, which is tension control. So therefore, round down tayo. Maximum na kasi yun, no? Hindi na tayo pwede humigit pa sa ating answer doon. So therefore, round down tayo. This is a special case. So therefore, 3 pieces lang yung kailangan natin. So therefore, the answer would be that will be. Yan, circle natin. Ayan, so proceed tayo sa ating next problem. So a reinforced concrete beam has a width of 300 millimeters and an effective depth of 618 millimeters. So compressive reinforcement natin, if required, will be placed at a depth which is 60 millimeters from the top. No? Kasi yung compressive reinforcement is nasa taas yung bakal, yung tension natin or tensile natin na reinforcement is yung nasa baba. Okay? FC prime na we'll be going to use is 28 megapascal and FY natin is 415 megapascal. So we'll be using 2010 NSCP, same lang din siya sa 2015 na NSCP. The beam is to support a factored bending moment, which is 600 kilonewton meters. So use natin na P is 0.9 for pressure. Okay, so proceed tayo. Ang first thing that we need to solve is the steel ratio for balance section. So, tingnan natin yung mga formula natin na sa itaas. Steel for balance section natin. Balance strain condition. Diba? So, yung merong 600. Ayan siya. So, yung 0.85 FC prime over Fy. Then, beta natin. Then, multiplied by 600. Ito. Pwede yan. Pwede to tatlo. Pero mas madali is yung last yan. Gagamitin natin. Yung 600 over 600 plus F1. Balance strain condition daw yung gagamitin natin. Okay? So therefore, lagyan natin yung kanyang formula. So sabi doon, raw natin for balance condition is equivalent to 0.85 multiplied by FC prime divided by sa ating F5 and then beta natin multiplied by 600 divided by 600 plus Fy. So take note, this is just a single layered. So therefore, wala na yung depth over dt. Kasi that is equivalent to 1 already. Okay? So, yan. Ang gagawin lang natin dito is for number 1, madali lang siya, substitution. So, raw natin na balance is equivalent to 0.85. Yan. Multiplied natin sa FC prime, which is 28. Then, divided by our Fy. Fy natin is 415. Multiplied ng beta natin. So, check natin sa FC prime, 28 sakto. If sakto siya na 28, same kanina. Therefore, that is 0.85. Diba? So, if it is greater than 28, iba na yung formula natin for beta. Yung mahaba na formula. So, 600 divided by 600. Then, given naman din yung Fy natin, which is 450. Okay? Check lang natin. Yan. So, therefore, by using our calculator, madali lang yan. Input niyo yan lahat. That is equivalent to 0.028882. That is our final answer. Lagyan natin ng line for number 1. Okay, so proceed tayo without much further ado. For number 2, sabi dito, determine the theoretical steel ratio required na raw for beam to support the given factored moment. So, therefore, we will respect our given factor bending moment. Hahanapin po daw natin yung actual natin na raw. No? So therefore, ano yung formula natin for our actual na raw? That is, kukunin muna natin si Rn. Di ba? Pagkuha natin si Rn, yung another formula naman, kukuha natin. Sulat muna natin yung formula ni Rn. That is equivalent to mu divided by phi d squared. Yan. Pagkatapos natin makuha, so muna natin. Mu natin, nasabi dito, no? Factored bending moment natin is 600. Take note that is kilonewton meter. So, gagawin natin Newton millimeter. So, multiply natin ng 10 to the power of 6. P natin is 0.9. D natin is equivalent to 300. Ayan po. Then ito yung width na 300. No? Then, depth natin or effective depth. Or actually, yung binigay na sa atin. Hindi yung total depth yung binigay, which is dapat minus pa tayo ng clear cabinet. So, dito, effective depth na talaga yung binigay. So, therefore, purely substitution. 618. Yan. Okay? So, therefore, that is our Rn. Therefore, by using our calculator, yung ating Rn is equivalent to 5.82. Ayan. So, carry natin. Kukunin natin yung raw actual natin. Lagyan natin ng raw up. Clear siya. Tingnan. Raw actual natin is equivalent to 0.85 fc prime divided by fy. And then open parenthesis 1 minus the square root of, am I right? Tama naman siguro. 1 minus 2rn divided by 0.85 fc prime. And siya. So, therefore, substitute lang yan lahat plus. Makukuha natin sa raw actual. 0.85 multiplied by our fc prime. Ano yung fc prime natin? 28. Divided by our fy, which is 415. Then, open parenthesis, 1 minus the square root of 1 minus 2, Rn natin is 5.82. Divided by 0.85. Then, fc prime natin is 415. Okay? So, therefore, close parenthesis natin yan. Then, use your calculator. Yan. So, by using our calculator, the result is equivalent to 0.01636. And that is the answer or our answer for number 2. Okay? Okay. Pasya. Number 3. So, letter C. Okay, try natin. So, for letter C, for number 3 dito, hahanapin daw natin yung required area of steel reinforcement. So therefore, yung area ng steel reinforcement, diba? Same ng ating one-way slab, we need to check if yung raw actual natin is hindi siya greater than or lesser than sa raw minimum. No? Hindi siya lesser than sa raw minimum, hindi siya greater than sa ating raw maximum. So ano yung gagawin natin? Take note that dito na tayo sa beam. Yung raw minimum natin for beams is 1.4 fy or divided by fy. So therefore, 1.4 divided by fy, which is 415. So that is equivalent to 0.00337. How about our raw maximum? So raw maximum natin for tension control, di ba? Nandun yung kanina, yung formula natin. That is equivalent to 0.85. Raw maximum natin is 0.85 multiplied by fc prime divided by fy. And then beta natin then multiplied by 3 over 3. Ayan. So, that is equivalent to, substitute mo lang yan, di ba? So, lagay natin 0.85, 0.85. FC prime natin would be 28. FY natin is 415. Beta natin, sakto na 28 megapascal. So, 0.85. Yan, multiplied by 3 over 8. Okay? So, therefore, raw maximum natin is equivalent to, sabi dito, 0.0182. Okay? So, next thing is, compare natin if saan dito sa tatlo yung gagamitin natin. So, yung raw mean natin is 0.00. Lapag na lang natin raw mean must be lesser than, or yes, lesser than yung raw actual natin. Lagyan natin ng blank. Blanco na lang kaya ng blanco. Blank. Then raw maximum natin. Lapag natin, raw minimum is 0.00337. Yung ating raw actual is 0.01636. Then raw max natin is 0.01828. So, clearly, na mas malaki yung raw act natin kaysa sa raw min. Di ba? Then, yung ating raw maximum is greater than sa ating raw act. So, pasok siya. Check, check. So, therefore, lagyan na lang natin dito, class, and sayang yung space or hindi na tayo on next page. Therefore, use natin si raw actual. Diba? So, therefore, the answer is this one. You may underline. Use raw actual. 0.01636. Ayan. So, I think hindi pa tayo tapos. Kasi yung hinahanap is yung area ng steel. No, hindi pa raw actual pa yan. So, therefore, we have next step pa. So, I think maliit lang ito na step. Lagay natin. Ayan. Delete. So, for number 3, lagay natin, di ba? So, we will be using raw. Lagay natin number 3. Raw up natin is 0.01636. Check natin. 0.01636. And then, kunin natin yung ating area ng steel divided by yung ating CP. Diba? So, that's our formula. Okay? So, therefore, area ng steel is equivalent to rho up times BD squared. Lagay ko na lang dito para hindi siya sayang sa space. AS is equivalent to rho actual multiplied by B. Okay? So, therefore, area ng steel natin, lagay natin yung rho actual, 0.01636 multiplied with our base, 300, and then yung ating depth, which is 618. Diba? Therefore, ang total natin na area ng steel is equivalent to 3,034 millimeters. Okay. And that is our final answer. Ayan. You can claim this na talaga. This is our final answer for number. Okay, so to continue. Dali na lang to for number 4. Hahanapin daw natin yung number of bars using 28 mm na diameter for tension na reinforcement. So meron na tayong area ng steel. So therefore, yung ating formula na number of bars is just area ng steel divided by ng ating area ng bar. Isang bar. Okay? So lagyan natin 3,034 millimeters divided by pi. D na gagamitin natin, diameter ng bar is 28 square divided by our so pi d squared over 4 siya. Therefore, by using that one, the answer is 4.93. So, hindi kagaya kanina na nag-round down tayo kasi maximum yung gamit. This is raw actual. So, therefore, gagawin natin is round up talaga tayo. 5 pieces. And that is our final answer po. Ayan. Okay? So, for number 5 and our last problem for this situation number 5. Sorry, last problem. Yes. So, determine the maximum number of 28 bars can be used for given section. Ilan daw yung bars na gagamitin natin for the given. Okay. Nandito ako saglit, no? So, ano yung gagamitin na natin ng bars, the number of bars? If yung gagamitin natin na row is yung maximum. Ayan. So, maximum yung ating gagamitin na row. So, therefore, yung maximum natin na area yung gagamitin natin. Okay? Nandito ako saglit, no? So, maximum number of bars. So, therefore, yung ating gagamitin na N is yung raw max, diba? Kunin muna natin na raw max natin. Wait lang. Ayan. AS natin is equivalent to raw max multiplied by BD. Siya. Kasi maximum daw yung gagamitin natin na bars. So, maximum na limit. So, raw max natin kanina, lipat natin is 0.1828. So, that is 0.01828. Diba? So, therefore, area ng steel natin is equivalent to, simulat yan. Okay na yan. P is 300. Depth natin is 600. Okay? Ayan. So, using our calculator, the answer is 3,389.112. So, therefore, gagawin natin is number of bars. AS natin is 3,389.112 divided by yung ating area ng 1 bar. Ayan siya. So, based on our calculator, the answer is equivalent to 5.5 pieces. So, that is 5.5 pieces. Take note na walang 0.5 na bakal. Ano yan? Hahatiin mo into half. Hindi pwede. And then, take note that this is our maximum, raw max yung ginamit natin. So, therefore, hindi pwedeng mag-round up, but rather than round down tayo. So, 5 pieces yung ating number of parts. Ayan. So, tapos na tayo for this problem. Okay?